Okay. Hi everyone, and welcome to my session on predictive maintenance of central heating system in residential buildings. My name is Mitra Hajigholi, and I'm a data scientist and machine learning engineer at Egain. I have 7 years of experience in creating and implementing advanced analysis for complex data sets using statistical programming. And at Egain, I develop machine learning models from prototype to implementation to draw insights from big data and turn it into a meaningful story to help customers create measurable business value. Egain has since 2003 been a leading technology company with digital control and energy optimization in residential and commercial properties. We develop steering algorithms, reporting platforms, and advanced IoT equipment for interconnected property systems. Egain optimizes heating for more than 300,000 apartments. We reduce their CO2 emission rate with over 22,000 tons in 2019. I'm proud to say that we have created value for people, planet, and business by connecting, digitizing, and optimizing buildings at scale. We control over 5,500 buildings, which means that we have data for different building types, which can help us understand their behavior in different situations. Predictive maintenance of central heating systems is a next step in our way of getting digital control of heating systems. And with this presentation, I would like to highlight why it is useful. And if you have any questions or comments, please write them down in the chat, and I'll come back to them at the end of my presentation. Okay, thank you. So let us begin by having a look at two maintenance cases. One is leakage and the other one is degradation. Did you know that 25% of all residential properties have leakage every month? An unnoticed water leakage of the tap water can fill up a deep pool in the substation or basement of about 16 square meters within weeks. Imagine noticing the leakage 1 year later. In fact, a leakage of the size of the head of a match will leak 3,000 cubic meters per year and cost 10,500 euros. The consequences are expensive, it's unsustainable, and can cause other damage on the house. Let's look at degradation. Did you know that problems with heat exchanger, walls, or heat switches can make a central heating system inefficient? And if a building becomes inefficient at using the incoming heat, it would return back a higher return temperature to the district heating system. Also, higher water flow will also be needed to keep the desired indoor temperature. Both of these can be extremely expensive outcomes for the building owner, and the system will eventually fail to keep up with this indoor temperature quality. And if you're lucky, you will have residents to complain about a low indoor temperature. But if you cannot find the problem, then the operational costs will continue to rise. Inefficient heating is important to identify early, especially for the cold rent market that is not controlled by tax of high energy usage. Such is the case in Sweden. So that's why it's very important. But what if the water leakage or the degradation would have been identified within, say, days or weeks? With an AI diagnostics, you would reduce your maintenance budget, it would take less time to repair it, and the residents would barely notice any change of the indoor temperature. And you would work sustainably. Well, there are some challenges with this. To understand and to learn when and why the central heating system is efficient and not. To understand when the heating system is inefficient, we need to measure that the building is energy streamlined, that the building is heated as expected, that the building, when you need repair or replace parts in the heating central to streamline the energy usage, and to be able to measure when there are any leakages in the house. But many of these have today no good way of being measured. So how do we do? There is a way to keep track of the efficiency of the heating central. There are some health indicators that we can measure and use. And they are delta T, flow, and power. Delta T is the cooling efficiency of a building of incoming district heating. In this picture, you can see the supply temperature from a primary circuit and the return temperature. And the difference between them is delta T. A measured high flow can indicate leakage in the primary or secondary circuit. But it could also tell us that we have a badly adjusted system between these two, the primary and the secondary system. And with power over flow, we can measure the heat efficiency of a central heating system. Now suddenly we have things we can measure and collect data of. So with these health indicators, historical data, and our energy experts' knowledge, and their experience, of course, we can start to develop a predictive maintenance model that could identify the water leakage or the degradation. You can reduce your maintenance budget, have happy residents, and work sustainable at the same time. Now it's possible. But how does predictive maintenance of the central heating work? Well, let's have a look at that. Briefly, the tool will automatically visualize and detect anomaly behavior of the central heating system using a powerful AI solution that analyzes more than 20 million data points each day. In your pocket, you're going to have full control of what's going on in your central heating system. To be able to use this AI tool, there are a few steps. To begin with, we need to connect us to your local infrastructure, as well as with a cloud service, to be able to collect important data for this AI solution. And for the machine learning algorithm, it needs to learn how your building reacts from varying outdoor temperature. So we'll need to collect some data for some time. Since Egain controls over 5,500 buildings, we have historical data for varying building types in different climates and countries in Europe. The AI can use this data and our knowledge to improve its self-optimization and thus improve its result for new building as yours. So what are the consequences? With predictive maintenance, it's now possible to analyze and perform of the central heating system in a meaningful way. It will give you reliability of the central heating system. You will now understand if it's inefficient at using the incoming heat, which is important for the cold rent market. It will also give you an early identification if you have an underperforming central heating system, which enables long-term planning of maintenance. It also allows you to reduce your maintenance budget. You can prepare for a replacement of malfunctioning heat exchanger or a heat switcher or a leaking valve or pipe instead of doing expensive quick fixes. It can also help you identify a badly adjusted system for the connection between the secondary and the primary circuit. And with a reliable central heating system, you will have a happy residents, of course. It will help you keep your indoor temperature goal, improve the comfort, and fix the problems in time. And last but not least, you can work sustainable by maintaining and replacing smaller parts before they become a big problem. And you can detect sudden increase of water or heat consumption. So let's summarize everything. Predictive maintenance of the central heating system can be seen as a long-term maintenance planning tool. You'll have smart control, simple installation, self-learning AI, and our energy experts' expertise. And you will achieve reduced maintenance cost, save time, improve your indoor climate, and increase your property value, which is the most important thing, right? So with this slide, I will thank you all for listening. That's all from me. Hopefully you learned something new. And if you have any questions, write them in the chat and I'll start looking at them right away. Thank you very much.